Good morning, class. You guys had some homework? The homework was on exercise 5.8. Exercise 5.8. Exercise 5.8. Okay. You had to do the whole exercise, not so? So what I'm going to do is I'm just going to take a couple of sums out of this, mainly the odd numbers. What sums did you have problems with? Which sums did you have problems with? 6. Did somebody say 6? No. Anything? So I'll do 1. So you guys had no problems. So why do you get what you get in the exam or in the class test if you understand everything? It's either you're lying to me or you're not doing your homework. One of the two. Okay, both is lying to me. Are you guys doing the homework? So why are you getting what you're getting in the class test? I don't understand. You're writing a test on this on Tuesday, no? You know you're writing your cycle test on Tuesday. Yes, you're writing on trigs up until this point. No, no, on trig as well. Geometry is 22 marks, trig is 28 marks. I'm not setting the paper. Didn't I tell you that? Yes, I told you. So I can't give you the breakdown if I didn't set the paper. Ms. Dixon must give it to you. 28 marks on this work. Trig. So this is exercise 5.8, page 120. Imagine you had to write on trig only, geometry only. To remind you how much you guys got for your class test in the geometry. Not I'm saying imagine you had to write on geometry only. Were you ready for it? Right, 5.8. In question 5.8 we are told that complete this exercise without a calculator. We are told that P, which is 3 and 4, is a point in the Cartesian plane. OP marks an angle theta with the positive x-axis. Determine OP. So remember in coordinate form that's an x and a y, there's a 3, since that's on the x-axis, and 4 since that is the length basically of your on your y-axis there, as you can see. So to calculate OP, I'm going to use Pythagoras. So OP squared is equal to 3 squared plus 4 squared. This gives you 9 plus 16, which is 25. The square root thereof, of course, is going to give you 5. So the hypotenuse is 5. Okay. Let's look at B. So sine of theta. Sine stands for opposite over hypotenuse. So it's 4 over 5. B. C. Sorry. C cos of theta. Cos is adjacent of hypotenuse. So it's 3 over 5. D. Tan of theta. Tan of theta It's going to be opposite over adjacent, which is 4 over 3. Okay, you all okay with that? Let's look at number 3. So here, we are given B to be negative 3 and 4. So we conclude the triangle, drop it perpendicular to the x. So that is going to be 4 and negative 3. But remember, that's x and a y. First question, calculate OB. So OB is the hypotenuse. So OB squared is equal to negative 3 squared plus 4 squared. That again gives us 25. The square root of 25, of course, is 5. You all agree with that? B, sine of theta. So sine is opposite over hypotenuse, so it's 4 over 5. C, cos of theta. Cos is adjacent over hypotenuse, so it's negative 3 over 5. D, tan of theta. Tan is opposite over adjacent, so it's 4 over. The next one, number 5, it says determine y if OQ is r equals 10 and q is negative 6 and 1. So again, conclude the triangle by dropping that point perpendicular onto the x. Always perpendicular onto the x. Remember, this is x and a y. So the x is minus 6, y is y. Your opposite is y there. Your radius is 10. Okay? So how do you calculate y? By using Pythagoras. So it's 10 squared is equal to y squared minus, so plus negative 6 squared. 10 squared, of course, is 100 equals y squared plus negative 6 squared is 36. Okay? You take 36 over the equal sign, becomes y squared is equal to 100 minus 36, which is 64. Now what? Square root both sides. No? You will introduce square root plus minus. So y is equal to plus minus 8. But if you look at where y is lying, that is on the negative part of y, not so. So that's going to be negative 8. Okay. But now you're going to ask, but why didn't I go plus and minus in the previous sum? Is because your hypotenuse here, or that length there, OB, is your radius. So radius or the hypotenuse will never be negative. Okay? In the first case as well, there, number 1, same story. That will always be positive. Hypotenuse or your radius will always be positive. Okay. Let's look at the next one, which is B. In B, so remember now this is negative 8. Okay. B, they want to know sine of theta. So what does sine stand for? This is my reference angle. No? Sine is opposite over hypotenuse. It's negative 8 over 10, which is negative 4 over 5. You always simplify. C, cos of theta. Cos of theta is adjacent, which is negative 6 over 10, which is negative 3 over 5. D, tan of theta. Tan is opposite over adjacent, which is negative 8 over negative 6, which is 4 over 3. What if they said cot? If it was cot, sec, cosec. Cot is the reciprocal of tan, so it would have been 3 over 4. Sec, reciprocal of cos, 5 over negative 3, and 5 over negative. You understand? So they don't have to always ask you sine, cos, tan in that order. They will just ask you sine and maybe cosec, whatever. Okay. So don't what's the name, yourself accustomed to this here. It could change. Alright, so that brings us basically to the end of exercise 5.8. Alright. Let's carry on. Let's see what else is there. What's next is negative angles. Okay, negative angles we'll leave for grade 11. Okay. So don't worry about negative angles for now. Your next heading is special angles. I want you guys to write this note here. Pause the video at this point. I think I must just give it to you out and the test out. Alright, listen, this is not a rummy sale. Relax your bones. Right, so we are told here that the angles 0, 30 degrees, 45, 60 and 90 are known as special angles. The trigonometric ratios of 30, 45 and 60 can be calculated from the sketches. Okay, so they gave you a sketch, but it's something you must remember. Okay, so what I do is I just show you a technique to set up your own triangle anyway. You see, what is sine of 30? Let's start with 30. Put in your calculator, what is sine of 30? Okay, so sine of 30 is R. So what does sine stand for? Opposite over? Hypotenuse. Opposite over hypotenuse is what sine stands for. Okay. So if you draw a triangle, okay, there's 30, 90. Sine is opposite over hypotenuse. Not so. So I need to work out, or find out what this length is here, which is your adjacent side. So how can we work out this length? By using Pythagoras. So let's call this your adjacent side, which is A for now. So it's going to be 2 squared is equal to 1 squared plus A squared. What is 2 squared? 4. This is 1. Bring it over the equal sign, becomes minus 1. Equals A squared. So A is equal to 3. A squared is equal to 3. Then A is equal to the square root of 3. Not so. And then what is the size of this angle here? 60 degrees. Okay? You all agree with that?
So wait, what?
Why is there 60? Who can tell me why is there 60? Angles and triangles add up to 180. So is 180 minus 90 minus 30 is 60. You understand? So now they could ask you, now without a calculator, you see I did this now, to get this other side's rule of this without the calculator. So that's going to be the root of 3. So they could have asked you, what is cos of 30 degrees? So what is cos of 30? Cos is adjacent over hypotenuse. So it's going to be root 3 over 2. What is tan of 30? What does tan stand for? Opposite over adjacent. So it's 1 over square root 3. Can you see that? What is sine of 60? Sine is adjacent, opposite over hypotenuse. So that's going to be the square root of 3 over 2. Can you see that, people? What is cos of 60? Cos is adjacent over hypotenuse. Can you see that? Cos of 60 is adjacent over hypotenuse. So it's going to be 1 over 2. What is tan of 60? Tan of 60. So opposite of adjacent, so it's going to be the root of 3 over 1, which is the square root of 3. Yes?
So how is 0 a special angle? 0 to 0.
I'll come to that now. Okay, you understand?
Yes.
So for the first things first, I'm going to say that triangle there, the first one would be 30, 60, opposite 30 is 1, 2, root 3. The first one, okay. So the first one deals with both 60 and 30. Okay. You all understand? It's on page 123. Okay. So that's how we can remember sine of 30 is half, and from there I can set up the triangle. Let's look at the 45 degree. What is tan of 45? What degree is 1? Okay. So it's going to be 1, which can be written as 1 over 1. Not so. So if I draw this 45 degree angle, there's 45 degrees. Tan stands for opposite over adjacent. So your opposite is 1, your adjacent is 1. So how can I calculate the length of the hypotenuse? Hypotenuse. So here your hypotenuse squared, let's call it h for now. The hypotenuse squared is equal to 1 squared plus 1 squared. What is 1 squared? And the 1 squared is 1, which is 2. Take the square root of that. Normally plus or minus, but this is length, so it's not negative. So h equal to the square root of 2. Not so? What's the size of this angle here? 45. This is your isosceles triangle. So now they can tell you, okay, what is sine of 45? What is cos of 45? We know what tan of 45 is, no? It's 1. So sine of 45, sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Tan is opposite of adjacent. You guys understand? So that is our second expression. But some of you I see sitting with a calculator and you're working it out. Remember, not in every exam you will be allowed a calculator. There will come a time that most of you are going to apply at university. They write what they call the NVT exam. Okay? And you write a maths test without a calculator. Okay? So when it comes to tricks, this is how we solve it. Using the special triangles. Should be able to draw it out way at that point. Okay? So 45, that's 45, this is 1, 1, square root 2. It's your second one. Okay? The next one? You said it's going to be your... Now, the next one, if you look at what they gave us in the textbook, okay? Just copy this. This is the one dealing with your your 0, so we dealt with 30, 45, 60. So 0 and 90 is what we left with. This is the diagram they work with. Okay? The diagram is a bit confusing, but let's look at it in this way. I'm going to draw something that's not a triangle, but it's actually going to work for what we're looking at, specifically for 0 and 90. Okay? So if you're looking at what is sine of 0, so you're going to calculate the sine of 0. 0. So that is 0. So 0, that's 0 over 1. So if I draw a triangle, I know it's not a triangle. Okay? Why? Because we can't have a 0 degrees there. There's normally 90. Not so. What does sine stand for? Opposite over hypotenuse. So the opposite is 0, the hypotenuse is 1. Not so. So I'm going to calculate your adjacent side to 0. Pythagoras. So it's 1 squared is equal to your opposite side squared plus your adjacent, your 0 squared plus adjacent side squared. So a squared is equal to 1 squared because that must falls away. So a is equal to 1. Not so. What would the size of this angle here be? 90. And there we go. There we got the 90 and the 0. As I said, this is not a triangle, but it works for what we're looking at. So here we can simply say, what is sine of 0? What's sine, cos of 0? What is the tan of 0 degrees? Sine of 0? 0 over 1, which is 0. Cos of 0? Adjacent of hypotenuse, which is 1 over 1, which is 1. Tan of 0, opposite over adjacent. So 0 over 1, which is, you see that people? What is sine of 90? Cos of 90, tan of 90. Now we're working with this here. That's now your opposite. So sine of 90, 1 over 1, which is 1. Cos of 90, adjacent of hypotenuse, so it's 0 over 1, which is 0. Tan of 90, tan is opposite over adjacent, so it's 1 over 0, which is 100. Okay, you guys understand? So we'll add that one now. As I said, people, this is not a triangle. Don't come to me Monday and tell me somebody told you to prove to me it's not a triangle. I know it's not a triangle. Okay? However, it's working for what we're looking at. Okay? We always see we put the asterisk here. So I know it's not a triangle. There's going to be 0, 1 and 1. Okay? So there are your 3 special triangles. Okay, or special angles represented in triangles. Okay. Okay, so let's look at an example dealing with this here. Looking at examples on page 124. Examples on page 124. Okay, so it says calculate by using special angles. Normally the sum says calculate without the use of a calculator. Okay, so then we should also know we're going to need to use special angle or special triangles. Okay. So what are the special angles? There are three. There's 30. So it's 1, 2, root 3, 60. The next one is for the isosceles triangle. Says 45, 1, 1, root 2. And the one that is not a triangle, but it works for what we're looking at, is 90. So it's 0, 1. You must memorize this. You'll be able to write it out for you. For every sum for now, just write it down. Okay, at the end of the next exercise, the homework, you should know it how to read. Okay. So sine of 45, sine squared 45. So whatever sine 45 is, it must be written in the bracket plus cos 45. Remember that sine squared 45 is equal to sine 45 squared. Did you see that? So what is sine of 45? Sine is opposite of hypotenuse. So it's going to be 1 over root 2. Can you see that, people? What is cos of 45? What does cos stand for? Adjacent of hypotenuse. So what's the adjacent length? 1 over square root. Okay. So 1 over root 2 times 1 over root 2. What's 1 times 1? What's root 2 times root 2? 2. Root 4. Not so? Which is the root of 4 is 2. So 1 squared is 1, the root of 2 squared is 2, plus 1 squared is 1, the root of 2 squared is 2. What is half plus half? That answer is any confusion here? Any confusion, people? No? Let's look at the next one. Calculate by using special angles. Again, that's going to be your 30 degrees. 1, 2, root 3, 60. The next one is your isosceles triangle. So it's 45, 45. 1, 1, root 2. And the one that's not a triangle, it's 0, 90, 90, 1, 1, 0. Okay. Now using that special triangles, I want you guys to calculate the value of this expression. Okay, so let's look at this quickly. Tan 45 squared plus times cos. So tan 45, tan is opposite of adjacent, so it's 1 over 1. Cos of 30, so it's opposite, sine of 30, so opposite of hypotenuse, so it's 1 over 2. Cos of 60, cos is adjacent of hypotenuse, so it's 1 over 2. So the 1 over 1 is 1, and 1 squared is 1 plus half times half is a quarter. So that's going to be 5 over 4 or 1 and a quarter. Alright, you guys understand? Any confusion there? Alright. For homework, I would like you guys to do exercise 5.9. Alright. Exercise 5.9 is on which page? Sorry? Page 124. People enjoy the weekend? Good morning. Yes?